Example 11, interpreting an inverse function. In example 3 in section 1.5, we showed that the mass of strontium-90 that remains from a 24 milligram sample after t years is m, which is equal to f of t equal to 24 times 2 to the negative t divided by 25. We want to be able to find the inverse of this function and interpret it. So the first thing we need to do is we need to solve the equation for t. So we're going to start by isolating the exponential and taking logarithms of both sides. So let's go ahead and write out the function. So we know that the function (24 times 2 to the power of negative t divided by 25) is equal to m. So the first thing we're going to do is we're going to divide both sides by 24 because we want to isolate the variable t in the exponent. So this is 2 to the negative t divided by 25, and that's going to equal m over 24. Okay, now in order for us to eventually get t isolated, it's in the exponent. So what we're going to have to do is take the natural log of both sides. So for step 4, we're going to take the natural log of 2 to the exponent of negative t over 25, and that's going to equal the natural log of m divided by 24. And now we got to use our logarithm properties. So our logarithm property that we want to use on the left side of the equation is we're going to use the power rule to bring the exponent out in front of the logarithm. So that's going to be negative t over 25 times the natural log of 2. And then over here, we're going to expand this division to subtraction. So this becomes the natural log of m minus the natural log of 24. So now what we want to do is we want to solve for t. And so in order to do that, we're going to have to multiply both sides by negative 25. And so what's left, we have t times the natural log of 2, which is equal to negative 25 times the natural log of m minus the natural log of 24. So before we go any further, let's just distribute this negative in front of the 25. So we're going to have 25, and so the natural log of m is going to be negative, so it's going to be minus the natural log of m, and then times the negative natural log of 24, which is going to become natural log of 24 is going to be positive. Now what we want to do is we're going to divide, in order to solve for t, we're going to divide by the natural log of 2. So t is going to equal 25 over the natural log of 2 times the natural log of 24 minus the natural log of m. So therefore, we can say that the inverse with an input of m is going to equal 25 over the natural log of 2 times the natural log of 24 minus the natural log of m. So what does this tell us? Well, this tells us that this function gives the time required for the mass to decay to m milligrams, and in particular the time required for the mass to be reduced to 5 milligrams, is the following. T, which is equal to F inverse for when the mass is 5, and we plug that into 25 times the natural log of 2 times the natural log of 24 minus the natural log of 5 gives us approximately 56.58 years. And so if you recall from section 1.5, this answer agrees with the graphical estimate that we made in example 3C, which was in section 1.5.